use engineering to design and create. We use technology to be able to make and to build. And then we investigate how successful it was by going back to the maths and the science. Here are some examples of technology with the science and the maths. Interesting though, we have an indigenous item on that. As you can see on the bottom, the woomera is an Australian indigenous tool. It's a sphere, but it has technology in it. Just not technology as we know it in our mobile phones. But it still is technology. About STEM. I hope you can keep a secret. It isn't really important what we call it. STEM, the reason I think STEM, the word or the acronym STEM, is sticky, is because it's easy. But there are so many variations. So it can be science, or it can be maths, or it can be science and maths together. It can have medicine. So at Curtin we talk about STEM with an extra M for medicine. Why that doesn't go under science, I don't understand. Then we have STEAM, if we put an R in it, if we put an A in it, if we put an R in it, we can have reading. We can make many, many different combinations. Does it matter? No, absolutely not, it doesn't matter. It's about building a cohesive and integrated approach. And as the deliberate or partial integration of whatever is needed, science, technology, engineering, mathematics, whatever is needed, stuff out. So, does that mean that you are no longer important? Well, I'd say no, I'd say you are very important, but not for the ability to remember. I would challenge you and say it is for your ability to use those skills that we started talking about earlier. Business skills, human skills, and digital skills. Now, you can see there are the 5 C's in human skills. They're the ones I'm particularly interested in and doing my research around. But you can see there are business skills, and then there are the digital ones. How do we protect our privacy? How do we not get scammed? Digital. How do we develop software? And how do we do it ethically? So, I thought this would be interesting. I'm interested in this. I'm interested in communication, collaboration, critical thinking, creativity. Let's have a look at what critical and creative thinking looks like. This is the difficult bit though. If you are saying this is important, how do we measure it? How do I measure that you're creative? How do I understand that you are a critical thinker? And what does that look like? It's a challenge for tertiary educators, it's a challenge for classroom teachers, and it's a challenge for you if you're not going to be a teacher. Because you have to say to someone, I'm a critical thinker. And they're going to say, okay, you say it, what does it mean? Show me how you can do that. So that's a challenge. We're looking at a more holistic review of STEM. Don't worry, I'm nearly finished because we're going to do an activity. Remember I told you we're going to do an activity. So we can use the notion of a global and local perspective. What I like to see is giving... Okay, let me explain what we're going to do first. We are going to build a pipeline. colleagues that you can work with. Alright, so normally when I do this, and this is my teacher thinking coming in, when I do this normally, I would get my students to do this about 25 minutes ago. But I know that it's going to be very difficult to get you back in from this activity, and so I'm going to run it now towards the end of my presentation. But this is about how engineers and how groups of people work together to solve problems. This is something, if you are a teacher educator, you may want to think about this in your classroom. This is a great activity for children as well. Pipelines are everywhere and they are critically important. This pipe is being built in Sarawak, and what you will notice is that they are not straight. They have to go around corners. They have to bend. They have to go up and they have to go down. So they have to be thought about when they're built. I want you, especially the teacher educators. Who are the teacher educators? Who are going to be teachers when they finish? Put your hands up, teacher educators. Starting on the chair. On the base, on the seat of the chair. So that is your start point. You have to make it 2 meters. 90-degree angle. 2 angles over 30. This I told you, it's not as easy as it looks. Oh, you're welcome to join the group. For smart students.
Okay. Come down.
I am going to give you 45 minutes to do this, and you are going to... Now, this gets super competitive at this point. The rules are that my decision is final. When I say stop, that means stop.
Yeah.
Okay, can I repeat that? Because nobody listens to that, right? When I say stop, we're done, we've finished. And then I go off and have coffee, you're still doing it, and we've stopped altogether, right? And I'm going to cope with obstacles. How are they going to manage criticism? Oh, we're not good at that, are we? My first years, I just finished their first assessment with me, my first unit yesterday. Today I'm having sad faces. You have to manage criticism, and you have to be resilient. And what about when other people are successful? Can you go, that's fabulous, or do you think, oh, that should be me? So think about this. The capacity to make the children excel and be their best selves, but you also have the power to admonish them and make them feel really bad. So please think about your power. Please think about how you can best prepare them for a very, very interesting and changing